Title: How do Grand Canyons form? Grand Canyons are among the most breathtaking features on our planet. Vast, rugged corridors carved deep into the earth by time, water, and forces older than human memory. When we stand on the edge of a canyon, whether it is the iconic Grand Canyon in Arizona or any of the many lesser-known but equally magnificent ravines scattered around the world, we are actually standing at the intersection of geology, history, and unimaginable time. The story of how Grand Canyons form is not simply a tale of rivers cutting through rock. It is the story of Earth's restless surface, shifting, rising, sinking, folding, and cracking through billions of years. It is the story of ancient seas, vanished landscapes, violent volcanic eruptions, and the slow, persistent work of erosion. And ultimately, it is the story of patience, because nothing on Earth forms more slowly, more subtly, or more beautifully than these enormous corridors of stone. To understand how these colossal formations come into existence, one must begin far beneath the ground, in the deep interior of the Earth where the forces that shape continents originate. Canyons do not begin with rivers. They begin with the land itself, whether it rises upward through tectonic uplift or collapses downward to form rift valleys. Without movement in the crust, without the push and pull of tectonic plates, there would be no dramatic landscapes for rivers to carve. The surface would be flat, lifeless, and featureless. But our planet is alive with motion. Continents drift across the globe, collide, and tear apart. Mountains emerge, plateaus rise, and as they rise, the stage is set for the creation of a Grand Canyon. Take the Grand Canyon of the United States, perhaps the most iconic canyon on Earth. Beneath its layered walls lies nearly 2 billion years of Earth's history. The story begins when the region was a flat plain beneath a shallow sea. Sediments settled at the bottom of the waters: sand, mud, silt, and the calcium-rich remains of marine life. Over millions of years, pressure turned these materials into thick layers of limestone, sandstone, and shale. Layer upon layer accumulated, each representing a different age of Earth. Then, tectonic forces uplifted the region, pushing the Colorado Plateau thousands of feet upward. What had once been underwater now stood high above sea level. And it is only after this uplift that a river gained the power to carve downward into the rock. Without uplift, a canyon cannot form. Water always flows downhill, and if the land is flat, the river simply meanders, depositing sediments, creating wetlands, deltas, and gentle curves. But when the land rises while the river continues flowing, gravity turns the river into a powerful cutting tool. Its waters accelerate, carrying rocks, sediment, and sand that act like sandpaper, grinding away at the plateau. The river cuts deeper. The land may continue rising. And over millions of years, this tug-of-war between uplift and erosion sculpts the canyon walls. Yet even this description oversimplifies the truth. Canyons are not carved by rivers alone. They are shaped by weathering, by freezing and thawing cycles, by landslides, by volcanic ash layers, by ancient earthquakes, and by the chemistry of water itself. Each force leaves its mark. Each contributes to the widening and deepening of a canyon. Erosion works like a team of quiet sculptors. Water cutting downward, wind smoothing the surfaces, the sun heating the rock by day and cooling it at night, causing expansion and contraction that gradually breaks the stone apart. Over time, massive chunks fall from the canyon walls, creating the steep vertical cliffs we see today. To truly appreciate the grandeur of canyon formation, consider that the Colorado River alone could not carve such depth without help from gravity and the climate. In colder regions of the canyon, water seeps into cracks, freezes at night, expands, and fractures the rock. This freeze-thaw action can break apart even the toughest sandstone. In desert climates, flash floods surge with enormous force, moving boulders the size of cars and scrubbing the canyon floor. Meanwhile, the wind carries tiny grains of sand that polish exposed rock faces, rounding edges and smoothing surfaces. In this way, a canyon becomes a collaborative work of nature's most patient and persistent forces. Not all Grand Canyons, however, are formed by rivers. Some are sculpted by glaciers, which carve deep U-shaped valleys as they grind slowly across continents. Others are created by the collapse of underground caverns, forming deep sinkholes and rugged chasms. Some are volcanic in origin, formed when magma chambers empty and the ground above collapses. Some are created along fault lines where plates diverge or shear past one another, creating dramatic rift valleys. Each type of canyon has a unique story, and each reveals something profound about the history of the region in which it formed. One stunning example is the Fish River Canyon in Namibia, one of the oldest canyons on Earth. It was formed not only by river erosion, but also by tectonic activity that fractured the crust long before the carving began. Another remarkable canyon is the Yarlung Changpo Grand Canyon in Tibet, the deepest canyon on Earth. Here, the powerful Brahmaputra River cuts through rising Himalayan mountains, creating a canyon deeper than even the Grand Canyon of the United States. This is a rare example where tectonic uplift continues vigorously even today as the Indian plate collides with Asia, creating some of the most dramatic and violent geological activity on the planet. Canyons can also form from catastrophic events. During the end of the last ice age, massive glacial lakes in North America burst through their ice dams, releasing torrents of water in what are known as megafloods. These floods carved channels through solid rock in a matter of days or weeks, landscapes that might otherwise have taken millions of years to form. These mega-flood-created landscapes, known as the channeled scablands, show that not all geological processes operate slowly. Some occur with staggering speed. But whether carved over millions of years or shaped in a geological instant, all canyons share a common trait. They reveal the deep layers of Earth's past. When you look at the walls of a canyon, you are looking back in time. Each layer of rock is a chapter of Earth's story. Fossilized deserts, ancient forests, vanished oceans, volcanic eruptions, and massive extinctions. A canyon is like an open book carved into the earth, and the deeper the canyon, the older the story it tells. Understanding canyon formation requires an appreciation for the concept of deep time. Humans experience time in days, years, and decades. Geological processes unfold on timescales of millions to billions of years. The formation of a canyon is slow, so slow that no single human could observe even a fraction of its progress. But the evidence is all around us, etched into the walls, the cliffs, the layers, and the sediments. By studying these features, scientists reconstruct how the world looked long before humans existed. Consider the incredible thickness of the Grand Canyon's rock layers. Some layers represent ancient dunes from deserts that existed 300 million years before the dinosaurs. Others represent muddy tidal flats populated by early marine creatures long extinct. Some layers formed during mass extinction events, preserving the ashes of volcanic eruptions or chemical signatures of climate change. A canyon is not just a hole in the ground. It is a museum of Earth's evolution. One of the most fascinating aspects of canyon formation is the role of climate. A wetter climate produces rivers with greater erosive power. A colder climate produces glaciers capable of carving deep valleys. A hotter, drier climate promotes wind erosion and intense freeze-thaw weathering. Climate dictates the rate of canyon formation, and shifts in climate can accelerate or slow the process dramatically. When the American Southwest transitioned from a wetter climate to a more arid one millions of years ago, the Colorado River's flow changed, altering its carving speed. Even today, climate change affects the flow of rivers and the stability of canyon walls. Geology also plays a role. Some rock layers erode quickly, while others resist erosion for millions of years. Limestone dissolves in slightly acidic water, making it easier for rivers to carve through. Sandstone can be extremely tough, depending on its composition. Shale crumbles easily. When rivers cut through alternating layers of hard and soft rock, they create steps, cliffs, ledges, and terraces, giving each canyon its unique profile. As a canyon deepens, the river that carved it may eventually flow through a narrow gorge, then widen into broad meanders, then narrow again as it encounters tougher rock. Over millions of years, the river migrates laterally, carving side canyons and tributaries. Rainwater runoff carves additional channels, contributing to the fractal-like complexity of canyon landscapes. In this way, a single river can create an entire system of interconnected canyons that stretch for hundreds of miles. But canyon formation is not solely a downward process. Canyons also widen over time. Rockfalls, landslides, flash floods, and frost-shattering break down the walls. As gravity pulls material downward, the canyon becomes broader. Some canyons that were once narrow and steep eventually become wide and flat-bottomed. Others remain narrow because the surrounding rock is exceptionally strong. The balance between downward cutting and lateral erosion determines the final shape of a canyon. A particularly dramatic example of canyon widening can be seen in the Grand Canyon's rockfalls. Massive slabs weighing millions of tons periodically shear away from the canyon walls, crashing to the floor below. These events can occur without warning, triggered by heat expansion, freeze-thaw cycles, or simple gravitational instability. Over geological time, these collapses play an essential role in shaping the canyon's iconic profile. Canyons also evolve as rivers shift their paths. A river may abandon an old channel and carve a new one, leaving behind dry canyons known as paleochannels. Some parts of the Grand Canyon show evidence that the Colorado River changed course multiple times during its early history. These abandoned channels help scientists piece together the river's ancient pathways. Some of the world's most extraordinary canyons exist underwater. Submarine canyons cut into continental shelves, carved by underwater landslides, strong ocean currents, and ancient rivers that once flowed across exposed seafloors when sea levels were much lower. These underwater canyons can be massive, some deeper than the Grand Canyon itself. They act as important conduits that transport sediments from shallow waters to the deep sea, playing a crucial role in shaping marine ecosystems. The Amazon submarine canyon, for example, stretches more than 750 kilometers offshore and reaches depths of over 20,500 meters. It formed partly from ancient river channels carved when sea levels were lower and partly from sediment-driven erosion underwater. These hidden canyons show that canyon formation is not limited to land. It is a global phenomenon driven by gravity, water, and the movement of sediments in all environments. Beyond Earth, canyons exist on other planets and moons. Mars, for instance, hosts Valles Marineris, the largest canyon system in the solar system. It stretches for over 4,000 kilometers, roughly the width of the United States, and plunges 7 kilometers deep. Unlike most canyons on Earth, Valles Marineris formed from tectonic stretching rather than river erosion. It is essentially a giant crack in the Martian crust. Over time, landslides and wind erosion widened it. The existence of such an enormous canyon reminds us that geological forces operate universally across planets. By comparing canyons on Earth with those on other worlds, scientists gain insights into planetary histories. For example, some channels on Mars appear to have been carved by ancient rivers, suggesting that Mars once had flowing water. This supports the possibility that the planet may have been habitable long ago. Thus, the study of canyon formation extends beyond geology. It contributes to our understanding of planetary evolution and potential life beyond Earth. Back on our own planet, human beings have always been drawn to canyons. They inspire awe, reverence, and curiosity. For ancient cultures, canyons were sacred places, gateways to the underworld or homes of gods and spirits. Many indigenous tribes still consider canyon landscapes deeply spiritual. The walls of the Grand Canyon, for example, contain countless archaeological sites that reveal how ancient peoples lived, hunted, farmed, and worshipped near the canyon thousands of years before modern exploration. Canyons present challenges, but also opportunities. They contain resources, offer shelter, and provide natural pathways for travel. Rivers flowing through canyons have served as sources of water and life for millennia. Today, canyons attract millions of visitors each year. They are central to tourism economies, scientific research, and conservation efforts. But with increased tourism comes the responsibility to protect these fragile landscapes. Although canyons may seem eternal, they are not immune to change. Human activity can accelerate erosion, destabilize canyon walls, and alter river flow. Climate change reduces river levels and increases flash flood risks. Pollution affects water quality. Mining, development, and dam construction disrupt natural processes. As stewards of the planet, it is our responsibility to ensure that these geological wonders remain intact for future generations. Understanding canyon formation is not only about appreciating nature's beauty, it is about understanding our planet's deep history, how it moves, breathes, evolves, and transforms. Each canyon is a reminder that Earth is not static, but alive with motion. The same forces that carved canyons also build mountains, create oceans, ignite volcanoes, and shape continents. These forces will continue long after humanity is gone. Yet for now, we have the privilege of exploring these towering corridors of time. When you stand at the rim of a canyon and look down into its depths, you are not just observing a landscape. You are witnessing the result of epic forces acting over unimaginable scales of time. You are seeing a masterpiece sculpted by the planet itself. In the end, the formation of Grand Canyons can be summarized in a single idea. They are born from the interplay of uplift and erosion, shaped by water and time, sculpted by climate, geology, and gravity. But that summary hides the brilliance of the details, the countless processes, the layered histories, the mysteries preserved in stone. A canyon is both simple and complex, ancient and ever-changing, harsh and beautiful. And perhaps that is why we are so captivated by them. They remind us of our place in the universe, tiny temporary observers on a planet that has existed long before us and will continue long after we are gone. They show us that even the most powerful forces work slowly, patiently, and deliberately. And they challenge us to think not in years or centuries, but in millions of years. Grand Canyons, in all their forms, are among the greatest storytellers of Earth's history. They are libraries of stone that reveal how the world came to be. They show us the power of water, the resilience of rock, the restlessness of continents, and the passage of deep time. Through them, we learn that the Earth is dynamic, creative, and endlessly surprising. As we continue to explore these geological wonders, we uncover not only the history of the land, but the history of life itself. Fossils embedded in canyon walls tell of ancient seas filled with strange creatures, forests long vanished, deserts that shifted across continents, and climates that changed dramatically over time. Each fossil adds a sentence, a paragraph, or even a chapter to Earth's biography. Canyons also reveal the impact of mass extinction events. Some layers contain iridium from asteroid impacts. Others contain ash from supervolcanoes. Others contain chemical signatures of ocean anoxia or rapid warming events. By studying these layers, scientists can reconstruct environmental catastrophes that reshaped life on Earth. This knowledge helps us understand how life adapts, evolves, and survives, and how it might respond to changes happening today. The story of canyon formation is also a story of interconnectedness. Rivers carve canyons, but rivers depend on rainfall, which depends on climate, which depends on ocean currents, which depend on plate tectonics that position continents on the globe. Every part of the Earth system influences every other part. The creation of a canyon is not an isolated geological event. It is part of a global network of processes that shape the planet's surface. Even the minerals within the canyon walls have their own stories. Some grains of sand may have once been part of ancient mountains that eroded millions of years ago. Some layers of limestone contain shells from organisms that lived in warm tropical seas long vanished. Some igneous intrusions represent magma that cooled slowly beneath the crust, only to be exposed millions of years later by erosion. By analyzing these rocks, scientists uncover the deep recycling processes of Earth's crust, where material is constantly being created, destroyed, and reformed. Canyon formation is not uniform. Some canyons develop steadily. Others experience sudden periods of rapid incision when rivers gain new power due to increased rainfall or sudden changes in elevation. Earthquakes can alter the course of a river, creating sudden shifts that lead to new canyon branches. Volcanic activity can block rivers with lava flows, forcing water to carve new channels. In this way, canyon formation reflects the dynamic and unpredictable nature of the planet. In deserts, canyons often form from intense but infrequent rainstorms. Flash floods can move enormous amounts of material in a single event. The narrow slot canyons of Utah, for example, owe their existence to these violent torrents. Their smooth, sculpted walls are the result of swirling floodwaters loaded with sand and debris. These slot canyons are among the most visually stunning geological features on Earth, reminding us that beauty often arises from chaos. In tropical environments, heavy year-round rainfall accelerates weathering and erosion, producing deep, lush canyons with vibrant vegetation. These canyons support unique ecosystems with species adapted to steep cliffs, cool shade, and constant moisture. Some rare plants and animals thrive only in these environments, making canyons important reservoirs of biodiversity. Over time, canyons evolve from youthful steep-walled chasms into mature landscapes with wider valleys and gentler slopes. Eventually, if erosion continues long enough, a canyon can disappear entirely, its walls worn down, its floor filled with sediments. Even the greatest canyons will eventually fade into rolling hills and plains. This reminds us that nothing on Earth is permanent. Not mountains, not rivers, not oceans, not even the continents themselves. The planet is always changing, always reshaping itself. The journey of a canyon from formation to eventual disappearance is a reflection of Earth's larger cycles. Mountain ranges rise and erode. Oceans open and close. Continents drift and collide. The Earth is constantly recycling its surface. Canyons are temporary features in this grand cycle, but they leave behind valuable geological records that help us reconstruct ancient environments and climates. Understanding canyon formation is also important for predicting natural hazards. Steep canyon walls are prone to landslides and rockfalls. Sudden floods can sweep through canyon floors with devastating force. By studying how canyons form and evolve, scientists can better assess risks to nearby communities, hikers, and infrastructure. Knowledge of canyon dynamics has saved countless lives. Despite the dangers, canyons continue to captivate the human imagination. Artists paint them. Photographers travel the world to capture their majesty. Filmmakers feature them in documentaries and movies. Scientists study them. Travelers flock to them. And people from all walks of life feel awe when standing before them. There is something humbling about gazing into a canyon, something that stirs the imagination and evokes a sense of wonder. Perhaps the allure of canyons comes from their representation of time itself, deep, ancient, and enduring. We live short lives in comparison to the age of the rocks around us. When we stand before a canyon, we confront the vastness of geological time, a timescale so immense that human history feels like a single heartbeat. This perspective reminds us of the fragility of our existence and the resilience of the world around us. As we continue to study and explore canyons, we not only expand our knowledge of Earth's natural processes, but we also deepen our appreciation for the beauty and complexity of our planet. Canyons tell us that the Earth is a masterpiece in progress, shaped by forces beyond our control but understandable through science. They remind us that nature is both patient and powerful, capable of creating landscapes that defy imagination. The next time you encounter a canyon, whether a grand, sprawling chasm or a narrow slot canyon hidden in the desert, take a moment to consider the forces that shaped it. Think about the ancient seas that once covered the land, the tectonic uplift that raised the plateau, the river that carved its path through solid stone, the storms that widened the walls, and the millions of years required to shape the landscape before you. Realize that you are witnessing one of the most extraordinary processes on Earth. And remember that every canyon, no matter how large or small, is a testament to the power of time, water, and the forces that shape our planet. In the end, the formation of Grand Canyons is more than a geological process. It is a story of Earth's past, present, and future, a reminder that our planet is dynamic, evolving, and full of mysteries waiting to be explored. Through understanding canyons, we come to understand the Earth itself. And through understanding the Earth, we gain insight into our own place within this ancient and ever-changing world.